Wearables are everywhere. In the medical field, they're transforming lives. Haiyan Zhang, Innovation Director at Microsoft Research, created a wearable for a young graphic designer that developed Parkinson's. This wearable allows the Parkinson's patient to write and draw again. Haiyan explained the research process and the technical aspects of how the wearable works. We also talked about the Internet of Things, the components of these systems, and the technical challenges.
VividCortex is the best way to improve your database performance, efficiency, and uptime. It's a cloud-hosted monitoring platform that eliminates your most critical visibility gap, providing insights at 1-second granularity into production database workload and query performance. It measures the execution and resource consumption of every statement and transaction, so you can proactively fix future database issues before they impact customers. To learn more, visit vividcortex.com/sedaily and find out why companies like Github, DigitalOcean, and Yelp all use VividCortex to see deeper into their database performance. Learn more at vividcortex.com/sedaily and get started today with VividCortex.
I'm here at Microsoft with Haiyan Zhang, Innovation Director at Microsoft Research. Haiyan, welcome to Software Engineering Daily.
Oh, thanks. Thanks, Edaena.
You design a wearable that helps steady the hand of a graphic designer that was diagnosed with Parkinson's at the age of 29, which is quite early. Explain how Parkinson's affects the human body.
I'm definitely not a medical expert, but I met Emma just over a year ago. I was participating in a TV show on the BBC, a documentary about sort of the power of engineering to solve real problems in the world. So I met Emma and, she's doing so well in her career. She's a creative director in London, but she's been diagnosed with Parkinson's about 3 years earlier. And, Parkinson's is a neurological disease. It's debilitating over time. It manifests in different ways in different people. There are multiple symptoms that people have to deal with day to day. They have to take a lot of medication. So the main symptoms are to do with kind of motor-based function. So Emma herself, she has tremors. So she is basically constantly shaking. When she performs an activity, the shaking can get worse. A lot of other people have a freezing gait, which is when they're walking down the road, they suddenly can't move their legs. The legs are frozen. Some people have a slowness of movement, and then they have also smaller movements. So they find that they can't make exaggerated big physical movements. So a lot of the symptoms are motor-based, and of course, this also affects speech. There's stuttering, and eventually it can affect sort of, internal organs as well. So yeah, it's a very challenging disease.
And what is the device that you designed to help Emma with her work look like?
We met, and her big challenge to me is that there is one aspect of her symptoms that she wanted to overcome. She's a graphic designer by training. She works with kind of computing and also with traditional sketching, drawing. She's also an artist in her own right. And she found that, because she had this tremor, she was unable to use a pen to write and to draw. She was constantly kind of shaking when she was trying to do these things. So she wanted to find a solution. She wanted to find a way to overcome these symptoms. So this is where I really went into this not knowing if I could solve this problem. And in fact, afterwards, the producers of the show said that they actually didn't think that I would be able to come up with a solution.
Why do you think they thought that?
They thought I would fail, and then that would make for a great documentary, I think.
Was there a particular reason that made them think that, as in it was taking time?
Because there isn't a solution. There didn't exist one, and it was unclear if, there's been decades of research into Parkinson's symptoms, and no one had found anything.
And what was the time frame that they gave you as part of this challenge for this documentary?
It took about 6 months.
Oh, okay.
So I really didn't know. And but I sort of leapt in and I said, okay, well, let's look at what we can do from an engineering perspective. So I tried out a number of different prototypes that were about kind of how can we make the pen more steady. I was using magnets. What if we have the writing surface is magnetic and the pen has a magnet on it, so the pen is kind of slightly stuck to the paper and it dampens her vibrations, her tremors. Other things like using kind of different drawing apparatuses. And then as a kind of very left of field, last minute prototype, I thought, well, I kind of have this idea, this hunch that maybe applying vibration to her hand will help her. And this really came about because I saw some other workarounds that people with Parkinson's use, and it kind of gave me this idea of what might be the problem. So to give you an example, people who have freezing gait, so that when they're walking down the road and they suddenly stop and they can't move, sometimes they have a metronome, which is it makes this ticking noise for musicians. So it goes tick, tick, tick. So they carry one of these and they turn it on, they listen to it. And this basically distracts their brain into, focusing on something else, and then they can walk again. So I thought, well, it's interesting that there's this phenomenon in Parkinson's where you might be able to kind of focus your brain on something else. Your brain is, at least subconsciously, focusing on something else. So maybe if we bring in vibrations, so instead of sound, we have this physical metronome, and we apply it to the limb that she's using, that, as a hunch, maybe it will work. So, I tried it and, I started kind of testing it with other people with Parkinson's, and, it seemed to have some positive effects. So I went from there.
Can you describe what the device looks like?
Oh, yeah. So I call it a watch. I guess it's kind of like a smartwatch, but it doesn't tell the time and it doesn't have a screen. So we used an existing strap from another product, and then we 3D printed a watch face case. We put the electronics in the case and on the strap. And on the face of the watch, we engraved Emma, because the watch is called the Emma. It's made for her. So that's what it looks like.
I saw a video where you show one of the first prototypes, and this looks like a big circuit board with lots of cables. What were the technical challenges of making it into a small wearable watch-looking device?
Right. I mean, it's a huge hurdle to go from tinkering to making a custom PCB. So here I collaborated with a colleague of mine, Nicholas Villar. He is an engineer, an electrical engineer, and we sat down and we said, okay, well, let's take this prototype, this kind of large development board, and let's make a custom PCB that is also wireless and can recharge a battery, and let's get it made. So basically we designed a circuit board. It has Bluetooth connectivity. It takes a battery power supply, and it also recharges via micro USB. And we pretty much made the board. It's got quite a powerful processor on it, so it can do a lot more. But we pretty much made it agnostic. So how you program it is that there is an accompanying app on a Windows tablet, and Emma can program the pattern of vibration, because we weren't sure exactly what kind of vibrations would help her. So we had this kind of very agnostic UI.
And you mentioned just now that the device connects to a mobile app. What can we learn from the data that is being sent from the Emma Watch to the mobile app?
So this is interesting. Since Emma received her watch and we've been working together on this, we're actually kicking off a clinical study with a neuroscience team in London. So this is where we design a protocol. So we have a number of tests, and we bring in people with Parkinson's with possibly similar symptoms, and they run through the tests, and then we'll do an analysis, a data analysis on statistically if they've made an improvement wearing the watch, not wearing the watch. And for this, we are capturing the tremor information on the wrist. So the watch is not only administering the treatment, but it's also capturing tremor information to feed back so that we can analyze that when the watch is on, does the tremor pattern actually change when the person is using it?
And the duration of the vibrations, like you said, is customizable, right, through the app?
That's correct. And, for the purposes of our clinical study, we've had to identify 1 to 2 different settings so that we can test against.
What are other new opportunities that you have seen for devices that are improving people's disabilities and in the digital healthcare space?
I think there is so much potential and opportunity for technology to play a role in improving people's lifestyles when they have chronic illness, debilitating kind of disabilities. At the moment, I'm continuing to work on this and thinking about, so we're proposing that as we move further along in this research, can we use this idea of wearables to help with other parts of the body, or to start detecting symptoms and offering other kinds of interventions, not just to help with tremors, but so for example, in the last 50 years in Parkinson's research, the medication, so the chemical side of it has moved very slowly. So can we use technology to improve the efficacy of medication? So these are other aspects we're looking at to improve overall lifestyle, not just kind of singular moments in someone's day. So this is where I think, this pattern, this idea can be applied to lots of other conditions, the idea of capturing data, biomedical signals, and applying interventions when needed.
Another area where I think the data might be useful, I don't know how the ear devices work for people that have limited hearing. They must be adjustable, right? Depending on the
hearing aids, yeah.
Mm-hmm. So more data-driven if you're in a quiet environment.
That's great. Yeah, louder. Exactly. This idea of feedback and contextual functionality is so important. I think, up until now, we do have existing technologies. You can buy a hearing aid, but now we have, I think there's the potential for reactive technologies as well. Yeah.
Yes.
Your application sits on layers of dynamic infrastructure and supporting services. Datadog brings you visibility into every part of your infrastructure, plus APM for monitoring your application's performance. Dashboarding, collaboration tools, and alerts let you develop your own workflow for observability and incident response. Datadog integrates seamlessly with all of your apps and systems, from Slack to Amazon Web Services, so you can get visibility in minutes. Go to softwareengineeringdaily.com/Datadog to get started with Datadog and get a free t-shirt. With full observability, distributed tracing, and customizable visualizations, Datadog is loved and trusted by thousands of enterprises, including Salesforce, PagerDuty, and Zendesk. If you have not tried Datadog at your company or on your side project, go to softwareengineeringdaily.com/Datadog to get a free t-shirt and support Software Engineering Daily. Our deepest thanks to Datadog for being a continued sponsor of Software Engineering Daily.
People are working on software to detect depression and other issues from smartphone data. Do you find this type of work promising?
I think there are a lot of signals in someone's life, in someone's day-to-day, that we can capture and use to deduce certain symptoms, certain problems, perhaps. I think there's a lot of signals. The question is, doing this kind of research, I think we need to be very careful in that, how are we picking these signals and how are we interpreting these signals? Can we be sure that if you're doing certain things on your smartphone, that this is an indicator of depression? But of course, I guess even if we have false positives, if we manage to help, one person out of a handful of people, then I think that's a plus. I think that is a win. I have an intern at the moment who is working on Project Emma, and he is also, looking at signals in relation to Parkinson's. So his PhD thesis is around capturing smartphone usage, daily digital activity to detect the progression of different symptoms.
And as we've been talking about small devices that connect and send and receive data, this shows that you've worked in the Internet of Things field. How do you define Internet of Things?
I mean, it's such a broad term now. It's such an exciting field, It's also, I guess, overused and overhyped as well. I'm very excited about the potential to now, going from the age of big room-sized computers to desktops, to laptops, to mobiles, to now think about new kinds of physical devices around us that might be imbued with smartness, that might be connected to the cloud to be even smarter, to serve us in our day-to-day. So I think the potential for this kind of technology to think about, as we're looking around on the desks, to see different gadgets, different objects, how can these things be imbued with smartness? I think that's how I think about the Internet of Things, this potential for new kinds of smartness with the inert objects around us.
And in this space, what are some of the business applications that you've seen with Internet of Things?
So it's interesting that, the Internet of Things is already being applied in industrial settings, in B2B.
What is B2B?
Business to business areas where, we might not see it yet, but it's already having a huge impact on how people run their businesses. Things like, supply chain providers that can track goods as they are shipped across the country, can track, a trucking company that can track their fleet and be able to optimize their business based on the data that is being generated, a factory that can monitor the equipment that they have and for servicing and maintenance to reduce their overhead costs, to reduce breakdowns. I think already this idea of sensing the environment and then talking with the cloud and doing analytics on that data is having a massive impact on business. And as we progress in the next few years, I think we're going to see more of that in our everyday lifestyles.
And in addition to this business strategy, the Internet of Things is appearing in toys. Why do you think this is happening?
So one of the aspects that I work on at Microsoft Research in Cambridge is around new kinds of play scenarios, new kinds of toy technologies. I mean, I could definitely go into a lot of detail on this, but something is happening with kids and with how they grow up. They are transitioning into the screen and digital games much earlier, playing with tablets, playing with, VR holograms, and perhaps coming off of toys, so weaning off of toys earlier and earlier. And I think there is an opportunity to think about, I think that there's value in kids playing with physical toys, but how can we imbue these physical toys with smartness so that the kids can still be attached to their toys, but still have a rich digital experience as well?
And related to this toys, earlier this year I saw on the news there was this teddy bear, Internet of Things teddy bear, that the information got leaked. What are the security risks with toys? Why is this very sensitive?
There is a dark side to the Internet of Things. If the objects around us are collecting data and uploading this to the cloud, then we have to make sure that the data it's collecting and the people it's affecting is protected, especially for the most vulnerable members of our society, which is kids. I think there are some approaches to IoT and toys that are misguided, which is thinking about, from the perspective of a business, how can we collect information, data from kids and improve our business? Mm-hmm. This is where I think we need to, as technologists, we need to really focus in on how can we provide the best value for the user? How can we make the experience delightful and make any data that we're capturing actually relevant to whatever it is that they want to do with their teddy bear or, with their devices.
And what happened with this teddy bear is you could send messages through the teddy bear to your parents or something. And what I saw was that it had to do with not very highly enforced password restriction and things like that. Is there maybe some miscommunication missing, as in, if you're going to set up an Internet of Things, these are the set of checkpoints you need to make sure. So, because what I think is there were some basic things there that were missed somehow.
Yeah.
So do you think there's still a gap in teaching more people what this takes?
This is a very knotty subject. I think consumers have an appetite for smart gadgets, smart door locks, smart drop cam, smart, baby monitoring. There's definitely an appetite and interest. There's a market there. And there's, lots of companies entering into this market and perhaps not as much focus on the underlying infrastructure. As you mentioned, data security is a huge issue. And because very quickly so many smaller players have entered into this market to launch products, there hasn't been this infrastructural layer being set up to account for the security. But I think that is slowly coming in. I think there is, now with these incidents, more of a focus on these issues. From a user experience perspective, you're right. I think there hasn't been any guidelines or design principles around how we make IoT devices. Sometimes that's good because then people are able to innovate and think outside the box. And sometimes that's not great because people can make products that have a huge gap. A colleague was telling me he was setting up a smart energy system in his house, and it took him hours. It took him a few hours, and by the end of it, he still hadn't been able to set it up because it was so complex, connecting things to the Wi-Fi, setting up the app, and how you access different, lighting devices in your house. And he said at the end of the day, he literally all he wanted to do was be able to turn on the heating. So all he did was he went into the wall and he just took two wires and then just tied them together. And he was able to turn on the heating instead of using this kind of smart home system.
So that definitely we're going to be seeing more improvements in this area in the next
years. I think there'll be lessons learned from a user experience perspective, and I hope, more designers share these experiences so that we can all improve our design.
And you come from a more traditional software engineering background. What was the transition like to design and working on human experiences?
I think I took an unusual route in that, I was a software engineer. I was working at a biomed company, and I just found that I wanted to have more influence in terms of the kinds of products we were developing rather than focusing in on algorithms and system architecture. I mean, I find that really fascinating, to solve a problem about, how do you architect the system, what pattern libraries you should use. The coding in itself is just a really enjoyable craft. But I found that, I really wanted to also influence what are the features we should be developing? Why are we implementing this particular feature? Is it really going to benefit the surgeons, the end users? So that's where I started transitioning into design and innovation. And I did a master's degree in interaction design, which is about designing the interface between people and technology. So I found that helped me to reframe my thinking from software engineering perspective to a user perspective.
And in an interview you did on Channel 9 with Rob Fraser, you mentioned that democratizing technology helped you explore other fields. How did this help you?
I would say in the last 10 years, we've seen this movement. Some people call it the maker movement, which is about, how do we make technologies accessible to amateurs? And also this kind of belief that you should be able to take apart the technologies around you and to thoroughly understand it. That, some people say, I don't own a thing unless I can take it apart and put it back together. And so I think there are so many great projects and great people working on making the activity of creating technology easy and understandable for everyone to use. So, things like making a web page, it's so simple now to just make a website. Whereas before, when I made my first website in 1993, and I was hand coding HTML. And, nowadays it's super simple. You can drag and drop, and you can be very expressive with technology with these tools that simplify the process of it. And I really admire this entire movement. So there's, with the development of the Arduino board so that everybody can start tinkering with electronics, with making their own gadgets. I just think that these tools are great for kids or for, anybody.
Or for small communities where other companies might not think to solving their problems.
Yeah, exactly. There are so many problems in the world that might only affect a small handful of people.
Exactly.
Case in point being Emma and, her particular symptom. Obviously, there are other people with Parkinson's with, these particular symptoms, but I think that the population is sometimes it can be quite small and not big enough for big medical companies to invest the money that's needed to find solutions.
Or like you mentioned at the beginning, part of the prototype was 3D printed. So if those technologies were not available, it would have been much harder to get a prototype up and running.
Exactly.
You're working in Microsoft Research. How can work that comes from research and this makers first movement be commercialized?
This is one of the challenges that I'm dealing with in some of the projects that I'm working on, which is, how do we bridge the gap between great research and great solutions for a small handful of people to scaling up to helping, maybe hundreds of people or thousands of people. I have a few different projects and they have different levels of ambition. We have some projects that are trying to scale up to be maybe helping hundreds of people, and then other projects that are trying to go mass market. And I think for each one, I'm trying to think through what is a bespoke go-to-market solution. I think it's different in every case, and I think we are leveraging lots of different tools like open sourcing, working with external partners in the specific industries so that to tap into their expertise. So I don't think there is a silver bullet, but I think if you have a team of people who are just very passionate and dedicated to getting this out, then we will find a way through it.
Last question. What technology are you most excited about in the next 10 years?
There's so many exciting new research, new technology research that's happening, things with bio, being able to manipulate DNA, organic materials, and how that might replicate computational processes is so exciting. There's, holographic and VR technologies. I think for me, to be selfish, what I would love is for technology to adapt to my needs and to what I want to do right at that moment. Because at the moment, I have to work around my day to use technology. If I'm texting, I have to, take out my phone and I have to kind of use my thumbs to kind of text. We have to bend ourselves to technology at the moment. And I hope that in the next 10 years, technology will bend to us so that in the moment that we need it, whether it's a personal assistant that we can just tell what we want to do and they'll do it for us, or something more invisible that predicts what we want to do at that moment. I think this is what I'm hoping, that we as humans can just live and fulfill our potential creatively, and that technology will work with us to do that rather than having us spend our day-to-day trying to sort of change ourselves to make technology work for us.
Or like you said earlier, a more reactive approach.
Yeah, exactly. And I think that's going to take a combination of things like, AI, things like new kinds of display technologies. Can we go from screens to just, holograms around us? New kinds of sensing technologies to detect what it is we're doing. So I think it will be a combination of things.
Haiyan, thank you for taking the time to come on the show. It was great talking to you today.
Oh, thanks so much, Edaena. I really had a lot of fun. I love this podcast. Thanks so much.
Thank you.
Simplify continuous delivery with GoCD, the on-premise, open-source, continuous delivery tool by ThoughtWorks. With GoCD, you can easily model complex deployment workflows using pipelines and visualize them end-to-end with the value stream map. You get complete visibility into and control over your company's deployments. At gocd.org/sedaily, find out how to bring continuous delivery to your teams. Say goodbye to deployment panic and hello to consistent, predictable deliveries. Visit gocd.org/sedaily to learn more about GoCD. Commercial support and enterprise add-ons, including disaster recovery, are available. Thanks to GoCD for being a continued sponsor of Software Engineering Daily.
Wow!